Welcome to this morning's webinar on So glad you could join us. My name is Dale Lutz. I'm a co-founder and vice president of development with Safe Software, and I'm joined by
Dave Campanis, product specialist at Safe Software.
And I also called you a Raster master here, Dave.
That's very kind of you.
Dave's been working with Raster data for how long in your professional career, would you say?
About 12 or 13 years.
12 or 13 years. And how many years of those at Safe?
6 now.
6. Okay, so almost the same amount of time before and after,
Yes.
but Raster all the time. So thanks very much, Dave. And I'm also joined today by Dimitri Bog. Can you holler hi to everybody, Dimitri?
Hi, everybody.
Okay, and Mark Stokes.
Morning, afternoon, depending on where you are.
Self-proclaimed FME rock star, it says here. That was actually a joke from what somebody said one time at a trade show that we were at. But he is truly an FME rock star. So we're joined by a lot of people that know a lot about FME this morning. And throughout the webcast, we welcome you to ask questions, chime in, make all of us sweat as you try to stump us with different questions. We're also going to be giving away some free training, online training for Raster. I don't think we've ever done an online training for Raster before. Is that right, Mark?
No, I don't think we have.
So you can be part of a history-making event. So before we get going at all, we'd like to get to know you a little bit better. And so I'm going to hand it over to my poll master, Aaron, to launch our first poll. And let's let Aaron do that. Here it goes. So we're asking you if you've used FME before. We'd like to get a sense of how much expertise and experience our viewers have today. And so, Aaron, are the results coming in? Are you going to be able to announce the results before tomorrow? I think tomorrow we find out in BC if we keep our sales tax or not. But we don't have to wait till then for this, I hope. So, okay, well, there's about 1/10 of you that haven't used. Are these being shared with everybody? So you can see for yourselves. We've got a lot of long-time FME users, but what we've found is that the longer you've used FME, the more likely you don't know that we do Raster. Because actually the story of Raster and FME goes back a long time. And the first probably 3 or 4 years of Raster and FME were a bit rocky. And so if you've been using FME a long time, you definitely want to stay tuned today. So Aaron, I think we have a second follow-up poll. Okay, and so this is really asking if you've used FME with Raster data or not. And so I'd like to find out or know where you're at with that. Obviously, those 10% of you that haven't used FME very much won't have done that. And this, I see the results are confirming my suspicion that I've had for a long time. It says fully, well, not quite fully 50%, but darn near 50% of you haven't used it at all with Raster data. And so hopefully today we'll show you some things that can definitely help you with that. So that's fantastic. I'm real excited to be able to present some of this to you. We've worked very hard for a long time on the Raster FME, and look forward to showing you some of the things that can be done. So as we get rolling here, just thought I'd introduce who Safe Software is. We're privately held by myself and Don Murray, founded way back in 1993, so we're starting to get old. We are headquartered close to Vancouver, BC, in beautiful Surrey, British Columbia. Not a lot of times you hear people use those two words together side by side, but it is a nice place to work. We have a good environment here. About 90 of us at Safe and literally thousands of customers. Oh my goodness, Dave, this says we're doing a demo right away. Did you know that?
No.
Okay, so let's just get started to quickly try to show you, and those of you that don't know much about FME, we'll get into what's going on a bit more later, but I wanted to do a quick demo which just showed how we can use FME to clip some things. So before we get going with anything in FME, we always want to know what we have for source data first. And so I've got this ECW file here for Austin, Texas, and if there are any attendees from Austin, Texas, a big thank you for making your data available years ago for us to base so many of our demos on. Dave, does this look believable as Austin, Texas?
Yes, it does.
That's good. Okay, yeah, there we go. So let me just zoom that to, so that it's always good to know what you're starting with, and we can click on this and see that we've got an RGB bit of data, and that's what our viewer helps us. We have a viewing tool that comes with FME that you can use to view any of our supported formats. And then I'm just going to, I'm just going to go and drag onto there this tab file, because I think this has some city parks in it. And yes, I see that the parks do overlay, so at least we know that we don't have coordinate system issues or anything wacky like that. So what I want to do is produce for each one of these parks. I'm just going to turn off the ECW here, and let's look at these parks. They all have a name on them. So there's Big Walnut Creek, which I think Big Walnut Creek is actually, that's the Northeast Park and East Destination. These things have different names on them. What I want to quickly do is make a different raster for every park. Do a clip like that. So to do that, I bring up my favorite FME workbench, and I get this is a blank workspace, and I'm just going to drag in the data that we want to work with. So I'm going to first drag in that tab file and add that to the workspace. So there's map info tab file coming in, and while that's happening, there it is. I'm going to just drag in that ECW. So we're just identifying some input and output sources right away. Okay, so there's my ECW. And now I want to do what's called a clip, so I need a transformer. Down in my bottom left is a transformer gallery, and I can search for the word clip, and I find out there's a guy called a clipper. And so, and I can see even what it does here in this description. It clips things. Well, that's a good thing. So I'll drag that in. And my clippers are going to be these city parks. And my clip E is that ECW. And I want to go, what's a good format to go out to, Dave, for images?
Generally, GeoTIFF is the most preferred.
All right, so let's just do that. And let's find a place to put this. Output seems like a good enough directory, I'd say. Okay, so I'll say OK to that. And that's going to set up an output writer. Yes, I'll add a new feature type. And I'm going to just let that go. Sure, that's fine. And I'm going to take and connect the stuff that was clipped on the inside to that thing. And I do need to tell this clipper that I want it to merge the attributes from the clippies, sorry, the clipper down to the clippies. So that means that now you can see that the clipper's name is on there. So now each one of these little raster pieces that's going to come out of the clipper, one for every clipping feature, is going to have a name on it. And I'm going to say to just fan out by the clipper name, which means we're going to name the output rasters by the name of the parks. And I'm going to run this thing, and with any luck whatsoever, there they go roaring by. Nothing as exciting as, don't you find these exciting, Dave, to see these statistics?
Oh, very exciting.
Yes. So we go over here, and output, oh, and there they are.
Wow.
And isn't that a pleasant thing to see? These nice little previews showing up of all these different parks. So that's what I wanted to just quickly show, that that little snap demo. So with just almost no effort at all, we clipped 22 parks out of an ECW and made a bunch of little images. So there's some funny things here because there's several Walnut Creeks, but that's because that park is actually divided into several pieces.
Yeah, and FME, in that case, FME will automatically auto-number the output images rather than overwriting.
Yes. And the other thing, if we didn't like that, we could assemble those all into one by, I guess, aggregating or joining together those multiple clipping polygons ahead of the clipper.
Yeah.
But we won't do that now. Okay, so let's go back to the presentation. So that was just a very quick little demo to kind of give you an idea. We were combining some vector data with some raster there and doing something interesting. So we like to say that FME is a tool that lets you achieve total spatial data mastery, or as I like to say, lets you put data in its place, where it belongs and where it can do something for you. So I just thought I'd run this proposed banner ad that we had thought of running a while ago to kind of poke some fun at me, because I did say that FME will never do raster, and it turned out that I was wrong, actually, and it took us a lot of years, but eventually we do raster, and we do a good job of it. So FME started off as a vector-only tool, and then with time we added raster. Raster first started being part of FME probably around 2003 or so, but it wasn't until FME 2007 that it really became usable, and we've really improved the performance in the years since then, as well as our ability to do high amounts of data volumes. What's the largest raster you've ever ground, Dave?
Probably about 300-400 megabytes.
Yes?
And that's probably small compared to most people's data sets these days.
Right, right. So anyway, we can definitely handle, and all of our stuff runs on 64-bit as well. So FME is a tool that sits in the middle between all these different types of data, and in specific today we're going to be talking about raster and vector, but mostly raster. You know, we do get usage stats for what people use FME for, and despite the fact that we've never really promoted the raster, around 5% of all FME translations are raster to raster translations. So just again, this shows that when you're using FME in your tool belt, you end up with a lot of different data types that you can work with somewhat transparently. So you don't care where you're coming from or going to. All these different data types are available to you, including 3D. And I did sneak in a tiny 3D demo at the end here, Dave. Actually, a couple of them to show that. Point clouds are also in there. If you're interested in that and you haven't seen it, we have archived point cloud webinars on our website. So raster, definitely one of them. So all these different data types are available. And FME Workbench is the tool that we use to set up these transformations from wherever we're starting to wherever we're going to. And the blue things in the middle are what alter or change the data as we go along. Now, the things you set up in Workbench, you can end up running them later on in batch. You can run them from the command line, or you can actually push them up to a server. So you don't have to stay living in Workbench. Someone can set up things, and then others can use them later. So before we get now, we're going to transition into all of the different types of operations people can do with raster. You can do it with that. But I'd like to ask Aaron to bring up our next poll, which is about what are your primary interests in terms of what kinds of challenges you have that you'd like to deal with. A lot of people interested in reprojection, so we're definitely going to talk about that. Mosaicing is always a sweet one, and we did learn how to spell it correctly as well for this webinar. So there's a K in there for mosaicing, which is non-intuitive, but a pretty even split across the first four, and not so much the second. We're just going to wait for a few more votes to come in. Okay, the poll is now closed, and here are the results. So translation, reprojection, very high. Mosaicing and tiling also very high. You surprised by that, Dave?
No. Actually, it's a common operation in mapping in the mapping industry.
Yes, and people do have lots of raster data, but what this points to is that it isn't always in the structure that they would like, in the packaging that they would like. So that's great. Okay, thanks, Aaron. Well, we're definitely going to be covering off on all of those challenges today. So, scenario number one, I'm going to go through about 11 scenarios or so today, talking about different raster things, starting from sort of easy things all the way to more advanced things. So, translating rasters. Well, in FME, there's more than 50 different formats to choose from, listing a few of them on this slide here for you to look at. Oracle Spatial GeoRaster is one that's a little bit less commonly supported by some packages, and we do a great job of that, as well as the database Esri side of things, GeoDatabase and ArcSTE and so on. Specialty formats like CD or G used by particular folks in the military. Of course, ECW, we read and write that, and Mr. SID is another one. Here's the whole list. Dave, do you have a favorite in this list?
I like GeoTIFF.
You do?
It pretty much holds any kind of data you want to throw it at, and it's georeferenced, and it's pretty much no muss, no fuss.
Right. And we also support the so-called big TIFF inside of GeoTIFF, which lets you have more than 4 gig of an image in one image. That's there. Don and I always are excited by the golden surfer. We wonder if that's one better than the silver surfer. So that's one thing. As well, actually we're coming up to Talk Like a Pirate Day, which is on September the 19th. And so that's the official day where R is one of our favorite formats then as well. But anyway, there's almost any format that you could want is in there. Oh, and I didn't show the example. So what is a simple raster translation? Sorry, look like? Let's look at this one, which goes. And that's what I was a little nervous about. So Dave, we'll just transfer over to you for this this demo. So are we able to do that? Okay. Is it still showing? Oh, if my screen is still showing, Aaron, why don't you just show it up there? And my display has, yeah, there we go. So as long as I can run it. Is that me? No, I don't have any mouse control, I don't think. So let's switch over to Dave, and I'm going to order a new Mac. Okay. So Dave, are you live there? One translate. Okay. Oh, there we go. Show my screen. Okay. And so now you need to. Okay. So Dave, if you can just don't show that one, just get rid of that. Are we live? Yeah. Okay. So let's bring up that CDED to GeoTIFF. There we go. And so that's what it looks like. It's as simple as that. And so we'll also have to get the presentation going here. You're live with that too, Dave? So we just switched drivers here. So we were down there. All right. So we are on Translate. Yeah, start the presentation there. So that was as simple as that down here. There we go. Yeah. Okay. So Translate, just to hop back, I'm going to just take control of Dave's computer here. I'm sure he won't mind. So yes. So it's as easy as that. A raster translation that goes from and to one thing is just that straightforward. So there's nothing much to it, and we'll just hop back to the slideshow then. So scenario 2 is resampling. And so Dave, can I get you just to, which is the file explorer? This one here?
Yes.
Okay, we'll go in here.
No, that would be, open up this one.
Okay, here we go. And I need my folders showing. And where is it in here?
Hang on. I bet you. Let me set you up in the right location.
Okay.
Here.
But anyway, resampling is just a way to reduce the number of pixels that you have, and we do support that in FME. So let's just take the, actually, you can just hit the folders button, probably will do it for us. Okay. There we go. Okay.
There you go, and you're ready to.
There we go. So we'll look at resampling. Now, one of the things with resampling is this issue of different kernels. And there we go. So it's as easy as that. You just put a resampler in the middle of your translation. And if we look at the properties here, one of the things is what kind of interpolation type you want to do. So we do support several of them. That wasn't always the case in FME. What do you recommend, Dave?
If you're doing imagery data, I recommend bicubic pretty much in every case. If you're working with strictly numeric rasters, then nearest neighbor is probably your best bet for something like a raster DEM.
Right.
We have some of the others. I'm not really sure why we include them. Pretty much everybody likes bicubic. There is a trade-off. Bicubic does take more time, but it does give you the best looking results by far.
Right. So anyway, that's if you're resampling. Dave did hit on an important thing. When we talk about rasters in FME, it's not just pictures, but it's also numeric rasters. In our demos today, we're mostly doing things with just pictures, imagery, but we can also do elevation models and other kinds of readings inside of a raster as well. Okay. So that's resampling. All right, reprojection. Well, I know a lot of you indicated you were interested in that. And so let's go back here and look. We've got a reproject example. So we'll just fire that up. And not surprisingly, the reprojection is not that different either. So there's a reprojector in the middle. And we can, again, do the kind of interpolation that we want to do.
Yes.
So that's that. And there's also this business of cell size if you are going from, say, a lat long where the cells aren't square on the earth to a state plane, you can indicate if you want us to let the cells, the pixels basically be stretched, or do you want them to be square, or do you want them to be exactly as they were? And so we can do any of those settings when you're reprojecting. And so we will do reprojection with NAD shift grids. So if this was a NAD 83 to a NAD 27, that would be all done properly, Canada, the US, or a number of parts of the world. We also have a number of other reprojectors. So if I'm in Ireland, for example, and hello to my Irish friends out there, there's a thing called the Grid Inquest reprojector. And that one is for using algorithms specifically for Ireland. And I know that my friends in Sweden love their G-Trans reprojector. So I've got a G-Trans one for them as well. And if you want to use the Esri reprojection engine, we have one there as well. So there's a lot of different reprojection engines that are available, and we can make use of them. So let's go back to the slideshow. Mosaicing. A lot of folks indicated that this was important to them, and so that's when you take a whole bunch of images that are small, that may or may not overlap, and you try to join them together. And so let's take a quick look at what a mosaic example would look like. So here I've got a directory full of tiles of images, and I want to just go and take a look at the workspace that pulls them all together and outputs just one thing. So I have my input, a mosaicer, and my output. Now the mosaicer, again, has some things like resampling and alignment. Dave, do you know what those are about? Can you explain them to the audience at home?
Well, occasionally the images that you're coming in are maybe the same resolution, but they're not aligned quite to the same grid, or they have a lower left origin point that's not aligned exactly to the same grid. In that case, we can adjust the source images so that they all sort of fall into the same alignment on the pixel centers. Yes. We can do a simple offset.
To just shift them a little bit?
Just shift them a little bit, or we can actually resample the source image. The offset is probably the fastest method.
Right. Resample would give you presumably more accurate results if it was a fairly big shift that's needed.
Yes.
If I had pixels that were like 10 meters in size and then the images were off by half a meter, or sorry, 5 meters, then I have a fair distance to go.
Yes.
So resampling might be better.
And again, you have the standard interpolation types as well, which are used in the resample operation.
Right. And so there's also this business of no data. When you're talking about rasters, no data is an important concept, and it basically means a special value that means you don't know what's really there.
It's an empty pixel.
Empty pixel. And so for mosaicing, we generally want empty pixels to be filled in. And so what these settings here on the data values tell us to do is if you lay down one image first and another image comes in that overlaps, if the one that overlaps comes in second and has no data, we do not fiddle with what was already laid down. So the first one in wins.
Yes.
And that is almost always what people would want to do. It's hard to see why you'd want to do anything different. What this does mean when you're mosaicing and the way FME works, individual rasters come into the mosaicer one at a time, and there is a transformer in FME called a sorter. Yeah. So you could imagine having a sorter ahead of time before you went into the mosaicer to, say, sort things by pixel size. So the images with the finest or most resolute value of pixel size, the smallest pixels would come in first. Those would be the most accurate. And then maybe you'd have a big overview image comes in last. That big overview image with the big pixels would only be used to fill in the parts.
Actually, it's the other way around. The first, it's kind of like a laydown model.
Yes.
Actually. So you actually want the overview down first.
Okay.
And then the smaller ones would actually be built up on top of those.
Okay. Yeah.
So it's like laying photographs down on a table.
Right. Right. So anyway, that's an important concept to be aware of with the mosaicing, is this issue of the order that things go in and filling in the various pieces and looking at it in that way. So compression. compression is a big part of Raster, and we support a number of formats that do have compression on them. And so I just thought I'd bring up an example here, looking at that. So I've got this scenario 5, which is compress after mosaicing. So this is a typical kind of situation. I've got a whole directory full, and let's just look at that input data. I've got these tiles in here. So again, it's these JPEGs, a whole pile of them, and I'm bringing them all together into Mosaic, and then I'm reprojecting and outputting the result to a single ECW. And what's this business about compression? Well, if I bring up the parameters of the ECW, on the right-hand side, I get to say how aggressively I want to compress. And so, Dave, in your experience, it looks like the default was 75. What do you normally recommend?
That's actually a good compression method. I think that gives you probably close to 25 to 30 to 1 compression on your output.
Wow.
ECW is a very high quality compression algorithm, and it's much better than the original JPEG. It is lossy, but it is not very lossy.
Right.
The amount of compression you get.
So you could crank this all the way to 99. Presumably, you would squeeze it even more. You'd burn more CPU, and you would lose more.
You might lose more. Actually, what happens, I think, generally is it takes more time.
Right. Okay. And then going the other way, a very light compression of, say, 10 would not give you that much of a file size reduction, but you'd get more speed when you're producing the output.
Definitely. Yeah.
Right. Bottom line is, to get to these factors, you look at the output feature type, and then you adjust the parameters over here for any of these formats that support compression. So that's a handful of them there. We don't write to Mr. Sid. To write to Mr. Sid, you need to have the LizardTech tools to do that. But we can read Mr. Sid.
Yeah, we can read Mr. Sid.
Okay, clipping. Well, I showed an example with clipping earlier. Again, we can cut pieces out. My little graphic shows them all being squares, but they can be any irregular type of thing. So if you look here, this is really very similar to the snap demo that I did earlier. So again, we have Mr. Sid coming in, and we're picking out only certain zones out of a zoning GML file, aggregating them all together so we only have one clipper for each one, and then finally outputting some results. So I'm going to just go and run this on Dave's computer, and we'll see what happens. One thing I wanted to point out here, it's busy reading that GML, and we do love reading GML at SAFE. Oh, that's bad because the output directory isn't there, Dave. So I need to, there's no Z drive on Dave's computer, so let's just put this data anywhere.
ctemp usually works best.
ctemp you like? All right, let's go to ctemp, c:\temp, and we'll call it Dave. Yes, let's try that. So then nothing is as comforting as seeing a nice red error message like this in the middle of a webinar, but nonetheless, the FME log file tells us what's going on when we're translating. I'm just going to run this again, and hopefully we get further this time.
One thing about the FME and writing Raster is we try our hardest to give you your error messages up front. Sometimes it might seem that the Raster translations in FME are overly picky, but the reason for this is that Raster translations generally take much longer than vector translations, so if something's going to go wrong, we want you to let you know right away.
Yes. Yeah. So there it's busy writing that TIFF out. While it's doing that, I just point out to folks that all these FME translations, it always shows you what the command line would be at the beginning of the translation. So if you look up here, we can see that this is the command line for running this, and so I could put this into a batch script or do whatever I want to and alter these input parameters at runtime. For example, outputting the things to a different directory than temp Dave, if I so felt. So there it is. It's at 93%. Doing that clip, and so then we're going to go to ctemp. Let me just get a Windows Explorer. Yeah, it's all done, and I'm just going to go to ctemp, and we'll take a look at that. C:\temp Dave, and there should be that single TIFF there. And what's your favorite viewer, Dave?
Your viewer actually works pretty well.
So just double click it. Is that what will happen? Yeah. Okay. And so we're just looking at it in a different package, and that's the image that we've got. So that was the zoning part that was cut out. that other image. So that's a simple example. And again, with FME, we also see the number of features. So we read 1,550 zoning polygons, of which 394 were in the zoning that we were interested in. We brought those all together into one feature, which we used for our clipper, and then we produced one image at the end. So that's kind of how that worked. The raster combo scenario, mosaic, reproject, clip, and make a catalog. And so I'd like to invite the folks at home, if you want to try looking at that link in your own web browsers, you can. We'll see if we can overload Dropbox, is where I have that sitting. You can try loading that up. We'll load it up ourselves after I show you the workspace. Actually, maybe I'll load it up first. If I click this, Dave, what's going to happen on your computer here?
I don't know.
Okay.
Oh, hey. Cool.
It's working. So the folks at home should be seeing this. So we managed to do a clip where we also produced some HTML at the same time and a little bit of information about each of the image chips. So that's pretty cool, isn't it, Dave?
Yeah, it's
and I think with luck, everybody at home is able to see that as well. So if you just go to that URL, bit.ly/parkcat. It turned out that park was already used on bit.ly. But let's take a peek at how that works. And Dave, you put this example together, so I'll get you to just talk us through it.
Sure.
It's an interesting one because it pulls together a lot of different parts of FME. So,
okay, it looks a little complicated at first, but most of the complication is due to the HTML stuff. What we're bringing in here is we're bringing in the map info park boundaries and the orthophoto, much the same as Dale showed in the snap demonstration.
Only this one isn't a bunch of tiles.
Yes, this one we're actually creating the tiles, and then we're just referencing them in the HTML.
Yes.
So the first thing we do is we run a raster mosaicer to mosaic the images together. We set the node data band on this to white, because we want a white background in case there's for the clipped areas.
Yes.
Next, we clip out from the mosaic all the individual park tiles. And then what we need to do is, as we saw later, some of the parks have multiple tiles, and we also saw that FME auto-numbered them as an output, so you wouldn't overwrite the files. However, because we want to reference these from the HTML, we don't know what each is going to be numbered. So I'm going to jump ahead of that, and I'm going to put a counter on these features coming out to auto-number them by their park name.
And then you concatenate it together with name_count yourself here.
Create a unique name for each park, even though it has the same name.
And now that you've done that, you're making a copy. Whenever these things fork like this, there's a copy going into two places. So one's going up top, and what's that about?
What we're going up top there is we're going to create a bunch of reduced images. So because this is a catalog, we don't need the whole resolution of the source image. What we need is just a small overview. So I run it through the Raster Resampler to generate a 10% overview. And if we open up the Raster Resampler, we notice that we have different ways of doing the size specification. So we can actually choose the size. We can choose a pixel size, like a pixel width, or we can choose a percentage. Now, in this case, it seemed most sensible to just pick a percentage of the original size. And that way, as you saw in our catalog, all the part sizes would be proportional.
Right.
Okay. And again, interpolation type is my favorite by cubic.
And now again, you're telling it something about transparent, or what's the alpha band about?
Yeah. What we did before is we set the node data value, and we actually created an alpha band to allow that background information to become white and transparent.
Okay.
However, in this case, we're going to JPEG, and JPEG, because it's a lossy, compressed format, does not support transparency. So we've got to squish it back down and get rid of that alpha channel and make it just a pure RGB24.
Right.
It's a white background.
Right, and that's what that step does. And then lastly, you're basically outputting the JPEG using that ability of FME to fan out by that image name that you made, which you know is going to be unique.
Exactly.
All right, so that's the top side of this. Now, what's going down down at the bottom here?
On the bottom, we're getting some information, putting some information together about these parks. Now, the park data is in Texas state plane, but most people, when they want to see like the boundaries in their area, rather than just a bunch of long numbers that are in meters, we prefer lat long. Everybody sort of understands lat long. That's what your GPS talks. So the first thing I do is I reproject it to lat long.
Yeah.
Next thing I do is I extract the bounds in lat long of each part.
Yes.
And that's how we create the extents, the upper and lower extents.
Now, I want to just mention to folks at home, one thing that you might think, I might say to you, Dave, aren't you doing a huge pile of work here reprojecting a whole image, all those pixels, just to get the bounds? And what would you say back to me?
It's kind of hard to explain, but FME kind of works on a pull model.
Yes.
For the data rather than a push. So when FME works, it kind of starts at the back end, and for each of the output parts, it looks and says, okay, what do I need? And then backtracks its way through the process and creates a single transformation for the entire process. So if you have any resampling, or if you have something like as simple like a bounds extractor,
yeah,
it knows that, hey, I don't have to do as much work.
Yes.
The other advantage is this: is if you're putting up together a bunch of multiple operations like a resampler and a reprojector, is that by combining them into a single operation, you only act on each pixel once. Now, whenever you do raster operations, cumulative operations on a raster, each operation degrades the raster somewhat.
Yes.
So if you do multiple operations in multiple steps, each step is a slight degradation of the image. If you do it in a single step, you only have that slight, very small degradation from that single step, and that's the way FME works.
That's right. So basically, we use for those of you that are longtime FMEers with vectors, when you put a vector in somewhere, we do whatever we're going to do at that moment. When you put a raster in somewhere, we just make a little note and say, okay, well, if anybody ever actually looks at this raster, we'll remember to do these things. And that lets us be smart, lets us combine multiple things into one operation, as Dave says. It also means in a case like this where we say reproject, we don't do anything, and when we do a bounds extract, all it does is just figure out the minimum effort that it needs to get the bounds.
Yes.
So that's an important bit of it, and that gives us actually very good performance. If you start with a ginormous image and then clip out a tiny little piece and reproject after that, we only actually reproject and read that tiny little piece. So that all adds up to good performance. So in any case, now you've got the, you've magically somehow got the bounds of this raster as a X and Y. And so now what are you going to do then?
Well, what we need to do is also put in the HTML reference to actually point to the image. And to do that, we have to know where the image is going to go.
Right.
So that's the reason I set up the unique name originally. So now we know the name of each file.
Yeah.
What I've got there is a parameter fetcher, and that parameter fetcher fetches the user input for the output folder. So the user has set the output folder. When he's run the translation, I go find out what that is. I have a little thing where a string replacer there. It's just an internal matter that reverses the path slashes to a more Unixy path, which is easier to deal with.
In HTML. And then here we're gluing together, you're actually building that HTML that we saw.
Yeah, building up the HTML reference for each image.
Yeah, along with the min and max I see in there, the lower left, and all that nice stuff being built all together. And then you basically glue that all together into one nice big string.
Yeah, and to the text line writer.
Right, and the net result of all of that is this here nice bit of HTML raster, park catalog.
Yeah, exactly.
So not that big of a workspace and a very nice output. So anyway, there it is again. If you haven't looked at it before, you can look at it now, but it's bringing together all of these things. Now tiling, switching gears, going the other direction, a lot of times people have very, very large images. And FME is not afraid to deal with large data volumes, but lots of other software, that's not very convenient. It's not useful for many situations to have such a big thing, so you want to chop it up into small pieces. And so let's take a look at what we got here for tiling. Whoops, tiling. And I do want to tell a story related to this, and I'm not sure if Robert White, a longtime customer of ours from White Star, is listening in, but this is precisely the scenario that he asked us to add to FME back in October of 2002. I have a note in my email that he wanted to take an image. In his case, it was a Mr. SIB, not an ECW. He wanted to reproject it into a state plane and then chop it into small pieces and output the result. He asked us in 2002. We couldn't do it then. We went away and tried different things. And in April of 2007, so 5 years and, well, not quite 5 years later, we finally got it to work. And I phoned up Robert and said, hey, I know it's 5 years later, and you probably moved on, but anyway, the thing that you wanted us to do, we've done. He said, I'll download the beta right now. And so he was very patient, and it just proves, I guess, if you wait long enough, your patience will be rewarded. But this is an example where we just reproject, and then we have this thing called a tiler. And again, there's a few different ways you can tile by size or the number of tiles. We'll chop it into basically little rectangles.
Exactly.
And then once we're done, we again are creating an output file name, tile underscore row and column in this case, and then we use again that fan out thing. A lot of times in the rasters we're fanning out by some kind of a name or an attribute that we created ahead of time.
Yeah, all of our raster writers are directory-based writers. So the feature type is the actual file name, and the output, the output's location that you pick is the folder that they reside in.
Right. So anyway, that's that kind of a scenario for tiling. And again, thanks Robert White for your patience and for inspiring us to greatness. And indeed, that does work well for him now. And that I know that on the night after he downloaded it, he reported back to me that he was having success. And if anything, it's only gotten better since then. So now, raster scenario number 9. Oh, and look at that. I've got another thing for folks to try at home. If we all, should we try that, Dave?
Go for it.
We were lucky on the other one on this computer. So if all of you want to try that, that's going to be, we're going to be banging on our friends at Dropbox, but it's going to start. Yeah, there, it's working. It's working. And so you can hide this overlay or show it, and then as we zoom in, with luck, yes, it's working. How about that? So how did that get done? Well, let's take a peek at how we can prep data using FME for use with, I guess, web map situations. So here's the workspace. And what do we have as input for this thing, Dave?
I believe it's a bunch of GeoTIFF tiles.
Let's take, is it in?
Yeah, so we have 4 GeoTIFF tiles.
Yeah.
That all mosaic together nicely.
Okay.
So I'll run through the steps here. As you can see, it's much simpler than the last workspace.
Yeah. But
the first thing we do is we use the raster interpretation cursor. And what I'm doing here is I'm taking the RGB images, or the red, green, blue images, and I'm adding an extra channel called an alpha channel, which is the transparency channel. And a reason I do this up front is that part of the mosaicing and the reprojector is going to leave little null pixels at the edge, as with the web map tiler, where the web map tiles don't exactly line up with the data tiles. So what I'm doing is I'm setting up a transparency ahead of time so that whenever FME does these subsequent operations, any area where we don't have any source data, FME will just make transparent.
Right. So that's a common step, I guess, as folks deal with data that doesn't have transparency in a workflow, get the transparency going early.
Yeah, and like we said before, because FME works on a pull model, this step actually doesn't make the data any bigger.
Right. It doesn't do anything. Yeah. So then we're gluing it all together that we talked about. We're reprojecting to that very special spherical Mercator.
Yep, that's the web map tiling coordinate system.
Yeah.
I think it has 3 EPHD numbers right now,
yeah.
One of which is valid.
Yes, okay.
But with just spherical Mercator, you know you're always there.
And then there's a transformer called the web map tiler. And so you throw it in there, and it basically chops that image, slices and dices again.
Yeah, if we go through the options here, at the top you have zoom level. Now, web map tiles have multiple zoom levels, so as you zoom in and zoom out, you're actually looking at different tiles. Now, I've left these blank because our web map tiler, if you do leave them blank, it optimizes the zoom level for you. So at the minimum zoom level, it will take the zoom level at which your source image occupies only a single pixel. And at the maximum zoom level, it will match the zoom level pixel size to best match the pixel size of your source data.
Right.
Now, if you want to override that, you're free to do so. And sometimes you just, for speed's sake, you might want to just produce a single zoom level, and you can do that as well by setting the minimum and maximum to the same number.
Right.
But in this case, I'm just letting the optimization work. Interpolation type, of course, is my favorite bicubic. And actually, this is one where bicubic is very important in that because you're doing a multiple number of zoom levels, if you do anything other than bicubic, you'll find that your top zoom levels, because you're sticking a lot of pixels into a single pixel, will get kind of noisy, get very noisy. Bicubic ensures they stay nice and clean, and you have a proper overview image that gives you the right overview for your data.
Right.
And at the bottom is just a bunch of attributes where we store all the information about that particular tile. The one we're going to be using is the quad key, which is some sort of hash number that scheme that Microsoft has come up with that gives you a unique number for every tile in the world.
Yes.
And the other ones are just the standard zoom level, tile column,
Sure.
tile row, raster index.
And then once again, you're just fanning out by that quad key.
By that magic quad key.
So right here. So that's just, and I'll just show the folks at home, when this is actually run in the tiles directory, we end up with piles of images that look like this.
Yeah, the neat thing about the quad key is that the number of numbers in the name tells you the zoom level.
Right.
The other neat thing about it is when we write out to formats that don't have an internal georeferencing, we have the option of creating a world file for them as well, just to store the georeferencing. But and in this case, I'm writing out to PNG format because it supports the transparent RGB32 image. But because the quad key is inherently it's georeferencing, we don't have to write out a georeferencing file.
Right.
So
right.
It's a very nice system.
So anyway, that's web map tiling. And so it's very easy to prep rasters for sharing with folks in that way. And I know that we've done it with huge volumes of raster. Dimitri, you've been involved in some massive web map tiling exercises, very large. So you can write into Dimitri and tell him your web map tiling needs. So now we're getting towards the end here. We've got a couple of draping scenarios that I thought we would just take a quick peek at. So let's look at 10 is a simple drape. And let's look at the output of that. I know that Dave, have you gone here to verify this output?
Unfortunately, no.
We'd like to go and verify the output, but we're just taking a raster and producing a nice 3D PDF. FME can do that sort of thing. And so why don't I show what that looks like. The input ingredients that Dave had for this was some, I guess, some shape files that were contours and then a JPEG of the area. And we won't go through this too much other than to say we're building a tin out of those contours, and then you're just clipping the JPEG to where that
to the boundaries of the tin, because we're going to take that
Yep.
JPEG and apply it to the surface that comes from the tin as a texture.
Yes.
So the texture has to be the same size as the surface.
Right. And so then we output a 3D PDF. Now we've got a more complicated one here that I just want to show. I'll show the result first. Let me get a little bigger window going here. So somewhere in here, down at the bottom, is my result. My German friends will like me calling this Überdrape. And then somewhere else in here is the workspace that made this. Where is it? There it is. And we'll take a look at that as well. So let's see if Überdrape has come up. It's a bit of a bigger PDF. It hasn't come up yet. But what we're doing in this one is we're bringing together lots of different data types. So we've got in here an elevation model, a raster, we've got some vectors, and then we've got a 3D collada model. And we're merging all of these ultimately into a single raster or single PDF. But along the way, we do one thing I wanted to show is this vector on raster overlayer, which basically burns the vectors into the raster, draws into the raster. So we kind of set some colors and then buffered a little bit to make them thicker, and then burned those vectors in before we overlaid them on our elevation model. And so let's take a look if it's here yet. And in a second or two, hopefully, it pops up. There it is. And so we can see we've burned into this thing the areas that we had those polygons. And I'm just trying to tip it up here. Dave's computer is, maybe your computer is asking for, there we go. Okay, so there we go. And you can see that we've got the lines in there of the roads that we drew in, and actually there's that 3D collada model of that house castle area is also burned into that PDF as well. So we can do this kind of data integration quite easily with FME. That ends really all of the demos we were going to do. I know if you have questions, we'll get you to start firing them in, and we're going to take those while we just sort of wrap up here. We didn't get into a lot of this stuff about expression evaluation. We can go pixel by pixel and calculate new values, extent calculation. Here's the whole list of transformers that in FME operations you can do on rasters. And Dave, is there any one in particular you'd like to highlight there?
Where is it? Actually, the raster expression evaluator, which is kind of in its infancy right now, but it's probably going to be the most powerful raster transformer on this page.
Right.
And that it allows you to set up an expression to manipulate pixels from several images, or have them interact with each other,
yes,
or interact with other data, and I think it'll be extremely powerful.
Yes. I also personally like the point-on raster value extractor. That lets me take vector points, look down into a raster, and fetch out the value, and then work with them in vector land. It's kind of like an overlay almost. So anyway, that's that. I thought I'd take a brief detour very quickly. My friend Dimitri set this up for me. It's no better data than Surrey, British Columbia. So we have a numeric raster of elevations, and we end up with vector polygons of elevation values. So we can go from raster into vector. And how does he do it? This is, again, in our beta FME 2012. Again, he uses the expression evaluator that Dave said to take our elevations and grind them into just 25 different classes. And once we have those, this is the raster to polygon coercer that goes and threads polygons of like value. And then we end up generalizing, smoothing that, and making a nice result. But that gives you just a taste of some things, again, on the high end, the power end that we can do.
Yeah, that raster to polygon coercer allows you to do a lot of classification operations based on your pixel values.
Yes. So I also wanted to point out all these niche raster formats that aren't for the kind of broad use, but for key people they are very important. Things if you recognize any of those acronyms there, then you likely know that they're important to you. But we can work with them, and some of these are very complicated raster formats as well. So I think we have, we're just about out of time, but one more poll here on an advanced raster webinar. You've seen us go through kind of what I'd call, or Dave and I would call, the bread and butter operations, but let's go ahead and ask folks, would you be interested in us doing another one where we explore some of these niche topics that we just sort of hinted at the end around expression evaluation, more about band coercion, restructuring bands, and so on. So once Erin is done, okay, she's closed that one. So thanks very much for your feedback on that, and we'll take that into account. Just to wrap up, today's webinar was recorded. You can watch this again and see how I handled it when my Mac, I guess perhaps in protestation over Steve Jobs resigning yesterday, when my Mac threw in the towel on me. Maybe that's a signing to go get a new one. But anyway, display quit. Sorry about that in the middle, but you can watch that exciting moment again if you want to watch it on the recording. And if you're new to us, please help yourself to a free trial of FME. We'll also be pleased to give you a personalized web demo, and that's available. We'll give you through email details about that, but just off safe.com. That's available. There's an intro to FME desktop coming up, another webinar soon, and we've got one coming on how do you actually set up data for display in Google Earth. And there's a pile of stuff. Dave, are you a Google Earth guy or not so much?
I'm a Google Earth guy.
You are. So I guess you'll be tuning into this one, will you?
I definitely will.
Good, good. I will be too. I actually know that they're going to, as much as I have troubles getting this done in an hour, they're going to have more troubles. Things like tours and dynamic live links and so on. Very, very interesting, all the stuff that can be done. And there's training that we're always doing online and in person. So just to quickly wrap up before we take questions, what you've seen today, I hope, is how FME can help you prepare and share your raster data quickly. So whether it's high data volumes you've got to deal with, whether it's grinding through lots of the same types of data things, doing transformations to make your raster more usable to you, and automate those things afterwards so you can use that workflow over and over again. That's what we hope we showed you today. And we'd be pleased. I think, Erin, we're going to make the workspaces available afterwards. This data is a bit big. When you're dealing with raster data, it gets big. It might be a big download. We'll figure out how to set that up for you. But if you want to try these things out, definitely you can. Oh, and there's a chance to win now, Erin. What do we have to do for that? There's a poll going. So let us know if you'd like a chance to be part of that history-making online raster training class in a couple weeks in September, and we'd love to have you there, and it would be a lot of fun for us to show you how to use this. For me, the raster and FME is something that I think we've under-promoted. It's a lot of fascinating, great functionality that can really help you get a lot of things done very quickly, so you can spend more time actually using your rasters than fighting with them. And so the more we can let you know how to do it, the happier I'll be, and the happier all those engineers and support people at SAFE that work so hard to make this will be as well. So we've got a couple of minutes here before we expire for questions and answers. I'm going to maybe ask Dimitri and Mark, you guys have been heads down the whole time. Has it been a little busy there? How's it been going? Mark's going to come in.
It's been very busy, and we've had lots of really good questions. Do we have a couple of minutes for questions?
Yeah.
So, question about mosaicing. Can we do color balancing across the tile boundaries?
Not at this moment.
Yeah. Okay. So that's good, because that's what I replied.
That's actually good feedback for the dev team as well.
Yeah, I think we're actually working on a histogram balancing tool, so that might be something that may be able to put into a workflow process once it's available.
Okay.
So we need to be able to do the histogramming before we can apply that. Yeah. A couple of questions about anybody using bags. So if anybody is using the bag, which is a hydrographic format that we just added to FME, just send a note in, because there are other users interested in how people are using that.
Actually, is that a bathymetry thing?
Yeah, that's a bathymetry raster thing. A lot of questions about mosaicing, actually, and one of them was, what are the rules or hierarchy for overlaps? So when tiles overlap, what are the kind of
right now it's a strict laydown. So it's like the best way to think of it is putting your photographs on a table. So the first one in the list is the least important.
Yeah.
Right.
So if you sort by lowest resolution and went up to the highest resolution, the higher resolution would win.
Yeah, I had we saw one scenario for where a person was using digitized maps, digitized historical maps, and we arranged them by date. So the oldest maps went down first, and the newest maps went down later, so it kind of updated as you went.
What about no data?
In this case, I think it honors no data value, but just to be sure, I always push it to a transparency, push the no data to a transparency using the raster interpretation cursor, and that is much simpler to deal with. So that no data becomes transparent, and transparency, there's a setting on the Mosaicer where you can say use transparency, and that I would always generally leave that turned on, and then the transparent areas will always show what's underneath.
Okay, that's good. I think that's probably enough. Have you got one, Dimitri?
We go rasterization.
Rasterization.
Yes. Yeah, or going between vector and raster and back.
Right. So we can go the one way with that vector on raster overlayer that we showed in the one example. That would be rasterizing vectors. There's also this output format called the GIF or ping rasterizer that has some. That's an old timer, a classic that can do some kinds of rasterization.
But we also have the image rasterizer transformer.
Oh yes.
That allows you to rasterize your vector data. It requires that you have a color set on your data. So you can use the pen color setter. There's basically helper transformers for that. The pen color setter allows you to set the pen color, area fill for polygons. We also have a nifty transformer called the text stroker.
Yes.
So we don't. The image rasterizer doesn't really do much with the way of text, but you can use the text stroker to stroke that text out into any true type font you have on your system, and then run that through the image rasterizer.
That's right. And I know that those of you that follow the FME Evangelist, and if you don't, you might want to, he is hinting on Twitter that he's going to do something showing FME working with Mapnik, and Mapnik is the ultimate, or an ultimate, open source rasterizer. So stay tuned for that. Well, we're going to wrap up. We'll be following up with some emails. Aaron and the crew down in marketing will give you the links to various things, including the recordings and the materials from this thing, and the dates of other activities we're doing at SAFE. So stay tuned for that. And I'll just wrap up by thanking you all so much for spending some time with us this morning. I really appreciate each and every one of you tuning in. I know that we've enjoyed presenting. I've enjoyed using Dave's computer impromptu, and I know Mark and Dimitri have enjoyed all the questions. We're going to stay around here answering questions. We do promise to not shut off the webinar, so we'll hang around. We'll turn off the audio, but we will be on the questions and answers for as long as anybody wants. But with that, I'm going to say that this is Dale Lutz signing out from Surrey.
And Dave Campanis as well.
And all the rest of the SAFE gang, wishing you happy FMEing.